Okay, in this chapter we're going to be starting to look at a whole bunch of radicals and rules and simplifying them, and yeah, there we go. First of all, we'll start off pretty easy. These are asking you to just take some square roots, and I think you can handle this. Basically, the sign that is in front of the radical will be the sign of your answer. So then the square root of 25 is just 5 with a negative in front, so negative 5. Okay, plus or minus the square root of 49. The square root of 49 is 7 with a plus or minus in front. This one, though, you have a negative inside the radical. And when you have a negative inside the radical, for now, you'll learn later in the chapter, but for now, what I want you to write is just that this is a non-real answer. Later in the chapter, you'll learn how to do these with what's called imaginary numbers, which you've never heard about before, but just hold on tight. That'll be, I don't want to give you a spoiler alert, okay? And then in the next one, if you have a fraction, you can take the square root of the top over the square root of the bottom. So this is really the square root of 529 over the square root of 2025. And if you don't know what either one of those numbers are, you can certainly type them into your calculator and do the square root symbol. But the square root of 529 is 23, and the square root of 2025 is 45, and you've got that negative that's out in front. Okay, and then same thing with the bottom one. Go ahead and stick that into your calculator as the square root of 0.0625, and you will get the square root of 0.25. Okay. Then next we have to simplify some radicals. There's a couple of different ways that you can do this. I honestly think that it's easiest to do this by prime factoring this, but some of you will figure out a shortcut that what you want to do is you want to find the biggest perfect square that goes into these numbers. Okay, so I'm going to teach you a couple of different ways to do these first couple, and then you decide whichever way you want to do it. Okay, first of all, I'm going to do this by prime factoring. And so prime factoring would be where I take 98 and I go, okay, 98 is an even number, so it's 2 times 49, and then 49 is 7 times 7. So my prime factor would be 2 times 7 times 7, okay? And then what I always tell people is that this square root symbol is in a really scary neighborhood, and all of these numbers right now, these prime factors, are inside the house, and they want to go outside the house. Okay, so pretend your radical is a house in a scary neighborhood. They want to go outside the house. But in order to go outside the house, there's this little imaginary 2 right there. And so to go outside the house, you need to be in pairs of 2. You have to have a buddy system. So the only ones that can go outside the house in this example would be these 7s because they have a buddy. So the 7, the buddy of the pair of 7s can go out, but this 2 that's right here has to stay inside the house because it doesn't have a buddy. So that's one way to do it. The other way to do it would be to go, all right, 98 could be 1 and 98, or it could be 2 and 49. 49 is a perfect square, so you want to rewrite 98 as 49 times 2, which really is the square root of 49 times the square root of 2, which is 7 root 2. Either way, you're going to get the same answer. The problem is sometimes it's harder to find factors of a number, so that's where people kind of go wrong, okay? So like on the next one, there's a whole bunch of factors that go into this, but I'm going to prime factor this one also. So I could go 2 and 150, 2 and 75, 3 and 25, and then 5 and 5. Okay, so now my prime factors are 2, 2, 3, 5, and 5. So now you can see, again, I've got this house that's in a scary neighborhood. In order to leave the house, you have to be in a buddy system. So I have a pair of 2s that can go outside the house, and I have a pair of 5s that can go outside the house. And inside the house, I have this 3, okay? On the outside then, 2 times 5 will make 10, root 3. So that's one way to do it. The other way to do it would be to go, all right, 300 is 1 times 300, or 2 times 150, or 3 times 100, and I go, oh, there's a perfect square, okay? And there's lots more. I could go 5 times whatever, okay? 5 times 60, all kinds of things. But I want to find the biggest perfect square that goes in there. So 100 goes in there, so I would rewrite 300 as 100 times 3, which is really the square root of 100 times the square root of 3, and the square root of 100 is 10 times 3. Okay, either way, I get to 10 root 3. However, whichever way you want to do it is fine. The next example, I have a number that's out in front already. So I need to break this 125 down. And so I will break the 125 down as 5 times 25 and then 5 times 5. Okay, so my prime factors are 5 times 5 times 5. Can't leave the house unless I have a buddy. So I have one pair of 5s that has a partner and gets to leave, but this other 5 that's over here has to stay by itself. Okay, so this is what I have. On the outside, I already had a 3 there, and then I need to put the pair of 5s, so one pair of 5s, and then I have the radical, and then this 5 that's by itself has to stay inside the house. So this would turn into 15 root 5. Okay, or I could go 125 is 25 times 5, so I could rewrite that as 25 times 5, which is really the square root of 25 times the square root of 5. The square root of 25 is 5, so then 3 times 5 is 15 root 5, whichever way you want to do it. All right. I feel like I'm missing some stuff. There we go. Okay, a couple more here. The square root of 128 this time. And so again, I will prime factor that. So 128 is 2 times 64, which is 8 times 8. And you know what? I don't even need to factor it any more than that if I don't want to, because I already have a pair of 8s that can go out. Some of you won't realize that, so I'll just keep going. I have a 2 and a 4 and a 2 and a 2. Oops. All right, so my prime factors are 2, 2, 2, 2, 2, 2, 2. Lots of them. So here's what gets to happen. I have a 2 already that's out in front. And then I have a pair of 2s. And I have another pair of 2s. And I have another pair of 2s. And then I have this 2 that has to stay inside the house because it doesn't have a partner. Okay? So on the outside, I have 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, which gives me 16 root 2. Okay? Or you could rewrite this as 128 is the square root of 64 times 2. The square root of 64 is 8, so 2 times 8 is 16 root 2. All right, then in the next one, and you're going to get lots of accelerated math problems like this, you can either simplify both of them or you can multiply them together and then simplify it at the end. So we will just go ahead and simplify this root 24. So root 24 would be 2 times 12, which is 2 times 6, which is 2 times 3. Okay, so my prime factors are 2, 2, 2, and 3. And I have this pair of 2s that can go on the outside. And then on the inside, I have a 2 and a 3 that have to stay there. So really that's 6. Okay, so what I have, if I bring this down, is I have root 3 times 2 root 6, which when I multiply that, there's a 1 in front of here. When I multiply those two together, I will multiply what's out in front, and then I will multiply what's in the radical. So 1 times 2 is 2, and then root 3 times root 6 is root 18. And now root 18 can be broken down again. Root 18 is not as simple as it can be, so I will break that down into 2 and 9 and 3 and 3. And so now I have this 2 that's out in front, and then I have a pair of 3s that can go out there, and then I have this lone 2 that has to stay inside the house. So this turns into 6 root 2. Okay, on the next one, we are going to break these down first. So hopefully you'll kind of start to see some patterns here. But 8 becomes 4 times 2, and the square root of 4 is 2, so this becomes 5 times 2 root 2. Hopefully you can see that, right? Square root of 4 is 2, so 5 times square root of 4, which is 2 root 2, becomes 10 root 2. Over here, this is a common mistake people make. 48, they'll go, oh, that's divisible by 4, and then that's 4 times 12, which is true, but you need the biggest square root that can go in there. And so 48 is also 16 times 3. So this becomes 4 times the square root of 16 is 4 root 3, which is 16 root 3. Okay. And now I need to multiply these again. I'll multiply what's out in front. So 10 times 16 is 160, and root 2 times root 3 would be root 6. And root 6, 6 can become 2 and 3, but notice neither of them have a partner, and so nothing can go outside the house. And so that root 6 is as simple as it can get. Okay, and that is that.